Okay, let's get started in SolidWorks. Let's go to File, New. I'm going to use the Advanced dialog for creating new files, but you can of course use the Novice one. But keep in mind that in the Advanced one, I can actually choose which templates I'm using. In my case, I'm using the templates I've provided in this series, so I do recommend that you do that. Once I open this up, we will get my default template. Now I'm going to show the default planes for a moment here, and let's have a quick side discussion about axis orientation. If you notice at the bottom right-hand side of the screen, we can see my little gnomon here that shows my X, Y, and Z axes. In SolidWorks, by default, Y is up and Z is forward. In the automotive industry as a whole, Z is up and X is forward. And if you talk to any automotive guy who does any CAD work at all, he's going to be religiously convinced that Z must be up and X must be forward, else the world will crumble and fall apart. Now, that is possibly an overstatement, but the point is that you may be tempted, of course, as a car enthusiast, to want to rotate things in SolidWorks so that Z is up and X is forward. Now, you can do that. You will see various people give tutorials on how to rotate things using this button right here, Update Standard Views. You could change it so that the Z-axis is now your top view and the X-axis is your front view. That works. It's okay to do that, but it's going to cause you all kinds of headaches down the line. Just be warned that you can change the views so that you are ostensibly working Z up in SolidWorks, but that change is not anything like pervasive within the application. So that, for example, your canonical sketch orientation will be sideways. Whenever you create a sketch, the horizontal constraints will be vertical and vice versa, which is very confusing. Also, whenever you look normal to a sketch plane, your whole car is going to turn sideways. It's just weird. So I don't recommend doing that. What I do recommend is sticking with the default axis orientation, Y up, Z forward, and then rotating your model if you want to export it for an actual automotive user, somebody who's using NX or CATIA or Alias or somewhere where Z up and X forward is perfectly easy to achieve. Next, let's talk about, just briefly, about the origin. Now, when we're working in a parametric CAD system, it's going to make our lives much, much easier if we work around the origin for each part that we do. The position of that origin is crucial, and we need to make sure that we are cognizant of that as we are working. So where do we want the origin to be in our final part? Well, let's go over and look at our final wheel. Now, if this were the only information that I had, I might be tempted to just stick the origin right here in the middle in the front of the tire, and that might be okay. If I, however, look at a more technical diagram of a wheel, I might choose that I want the origin to be right here at the center of the mounting plate where the wheel mounts up against the axle. That makes a lot more sense from a mechanical point of view. It would be right here at the middle of the center bore on the back side of the rim, and that gives us a nice flat face. There are a lot of reasons why that's a good place to be. So what we'll do is consider our right plane to be this plane, that mounting plane where the wheel meets the axle, and then we will offset a plane for the front spacing. That'll give us that number, and then we'll offset a plane to the back, and then grab one center plane to grab the center line of the wheel itself. So let's just do that really quickly. I'm going to go to my right plane here, control drag that out, and this first distance is going to be that front offset for the wheel. Now, I've done a little bit of research on this. I have not been able to find the exact front offset spacing for this particular model of car. I have found a nice chart with a lot of comparable numbers from other 911 models, and I've been able to find that the front offset spacing is almost always between 50 and 60 millimeters, sometimes 52, sometimes 57. It can be anywhere in there. It's very rarely less than 50 or more than 60. So I'm just going to call this 55 millimeters to start with, and we'll just call that our norm. Now, if you were to discover later on that that's a different number, we can change that. So let's call this our front offset. I'm going to control drag this guy back, And this is going to be the overall width of the wheel. This is an 8-inch rim in the front. We're going to have to do separate ones for front and back. So let's call this 8 inches, which is 203 millimeters, of course. We'll hit OK, and that'll be just fine. We can call this our inner face. And then finally, I'm going to hit that S key for my shortcut menu. Now, my shortcut menus are heavily modified. I drop in all of the stuff that I tend to use frequently. I just don't like coming up to the ribbon. I find the ribbon very inconvenient to use, and I just dump a bunch of stuff in here. Now, the one I'm including in the tutorial materials is going to look very similar to this, but it won't be identical because this is going to be evolving over the course of this recording. As I record, I'll be adding tools to this as needed, and so those will appear as well in your final toolbar. If you want to add or remove something, of course, you can just right-click on this menu and click Customize, and then from here, you can head to your shortcut bars, select stuff, drag and drop it in there to the Shortcuts bar, and when you hit OK, we'll be back to our menu, our modified menu. Okay, so I'm going to grab the plane tool here. I'll select this inner one and this outer one. That gives us a mid-plane by default. I'll just hit OK, and we'll call this our center line. And there we go. Now we have enough planes to actually begin working. I'm going to hide the default planes because really what we care about are these ones for the moment, and we can get started.